Give me 7 minutes and you'll leave with a clear, testable picture of what China's Zhurong Rover actually found on Mars, and exactly where the speculation stops. Keep a pen handy. You'll record 3 dates and make one honest decision before we finish. First, the frame. Zhurong touched down on the southern margin of Utopia Planitia in May 2021, CNSA 2021. A flat, deceptively quiet plane, first visited by Viking 2 in 1976, NASA 1976. The rover carried cameras, a laser spectrometer to break rock and read light, and, crucially, ground-penetrating radar that peers tens of meters below the sand. Safety drove the landing choice, but radar turned flat into layered. And layered ground is a history book when you know how to read it. Here's your early challenge. Write the numbers 1976, 2021, and 2028 on a small note. Then circle the words mechanism before meaning. The radar traced stacks of subsurface packages beneath a regolith cap, each package dipping toward the north into the deeper basin. On Earth, that geometry screams migrating shorelines. Waves and currents sort grains, shore faces prograde, and layers tilt with the direction of growth. On Mars, the same geometry implies repeated episodes when water pooled in the northern lowlands, waned and returned. It is not poetry. It is stratigraphy doing arithmetic with sand, salt, and time. Write 1976, 2021, and 2028 on a card and underline verification today. Landing is hard. Now shrink the scale from basin to dune. Zhurong rolled onto low, elongated dunes scattered across the ancient seabed and found something stubborn. A hard, salty crust binding the top few centimeters like brittle glaze. In a world scoured by wind, delicate coatings should shred, not persist. The simple mechanism is quick wetting. Frost or snow settles onto salt-rich grains. Salt depresses the freezing point. Brief brines form, then evaporate, leaving cement. That is blink and it hardens behavior, recent enough to survive erosion. Before we sprint to meaning, separate water into 3 buckets. There is oceanic water that fills basins for geologic spans. There is groundwater that percolates, freezes, and hides. And there are brines, salt-fortified liquids that survive below zero for minutes to hours when conditions align. Keep those distinctions clear, and the story stays disciplined instead of mythical. Sketch a 2-line cross-section with a regolith cap over north-dipping packages tonight. The Viking parable belongs as guardrail, not clickbait. In the 1970s, Viking landers dosed soil with nutrient solution, saw gas on the first go and less on the second. Mainstream interpretation favored non-biological chemistry because it explained the full pattern with fewer assumptions. A minority later wondered whether hypothetical desiccation-adapted microbes, if they existed, might be overwhelmed by liquid water. The lesson is not to endorse a ghost, but to design tests that don't break what they seek. Follow the data. Engineering made Zhurong's conservatism coherent. A parachute bled speed in thin air. Near the ground, a throttleable engine eased the descent, cut off just above the surface, and legs took the last shock. That older playbook worked because the rover was modest in mass and the terrain forgiving. Perseverance, by contrast, descended into a hazard-rich crater and used a sky crane to drop a car-sized laboratory. Different payloads, different risk budgets, same physics, same humility. Mini vignette, fear of opinions. You're editing a voiceover and hesitate before saying, brine wetting events. Will the comments accuse you of hedging? You keep the phrase, add a simple frost to brine graphic, and trust viewers who care more about mechanisms than slogans. The 2 Zhurong findings interlock like gears. The layered north-dipping subsurface points to large-scale water episodes in deep time, plausibly tied to a northern basin. The dune-top crusts hint that thin films of liquid may have visited the surface in the geologically recent past, perhaps within hundreds of thousands of years. But that does not mean rivers run today. It means climate cycles can still shuffle ice and vapor, writing tiny wet signatures on an old ocean floor. Name the instrument, state the geometry, and choose one careful verb for clarity. What drives those cycles? Mars's poles stockpile ice. Modest changes in orbit and axial tilt modulate sunlight, nudging ice to sublime, drift, and recondense at lower latitudes. Salt left by ancient seas lowers melting points so seasonal, frost can momentarily wet grains into brine before the thin air strips it away. No mythology required. Cycles, salts, and time do the work. Short-lived brines mark activity, not sustained habitats. Write one plain sentence that survives cross-examination tomorrow morning. Tianwen 3 is the hinge. Plans call for a dual launch campaign around 2028, CNSA 2028, to land, core, and loft samples into Mars orbit for return to Earth. Samples beat debates because laboratories can date minerals precisely, trace isotopes, and search for organics without a rover's mass shackles. If dune crusts really formed from brief wetting, geochemistry should catch their salt fingerprints. If subsurface packages are shoreline consistent, textures and grains will confess under a microscope. Site choice matters as much as hardware. A cache that blends dune rind material with nearby host grains lets geochemists compare salt signatures against their parent sediment, ruling out contamination pathways. Targeting shallow layers tied to the radar-imaged packages links surface chemistry to subsurface architecture. Perchlorates and other oxidants complicate organic preservation, yet they record fluid histories in their isotopes and bonding. Radiation damage is real, but shielding improves quickly with depth. Even dosimeters matter. A disciplined plan samples rind, host, and context, documents exact orientation, and logs temperature history from drill to seal. In the lab, correlative microscopy, micro-CT, Raman, and nanosims build a layered verdict rather than a single fragile claim. Mini vignette, digital noise. You open 10 tabs. 8 headlines shout, "Ocean proved," or "Life soon." You close them, keep a methods section and a preprint, and change one verb from flowed to wetted. Your shoulders drop. The script breathes again. Design discipline operates at centimeters and decades. At centimeters, pick sampling methods that won't sterilize fragile targets. Respect salt chemistry, throttle water budgets, and preserve ambiguity when evidence runs thin. At decades, match power systems and dust strategies to science goals. Solar and short is fine for reconnaissance. Nuclear and long is better for life detection. Both choices are conservative. Both pay dividends for truth over theater. Dust wins slowly. Solar panels buy simplicity at the price of vulnerability. Zhurong was spec'd for roughly 90 sols and worked for about a year before sleeping through a dusty season. Sunlight and temperatures returned, but the rover stayed silent, likely pinned beneath clingy dust. That is not failure, that is Mars billing for services rendered. Whenever you compare missions, compare lifetime constraints and environments, not just highlight reels. Mini vignette, boundary with a draining tie. A collaborator pushes to open with ancient ocean confirmed. Because it clicks. You answer, we lead with radar layers that dip north. Ocean stays a model under test. The meeting cools. The project stays honest. The audience you want to keep notices. The YouTube problem is tempo, not truth. Brains tune out when words outrun pictures. This story's pictures are plain and strong. A radargram with dipping packages, a cross-section of an advancing shoreline, a dune crest with a hard rind, and a 3-date time limit, 1976, 2021, 2028, linking first touch, fresh evidence, and verification under glass. Put those on screen and let the geometry carry the weight. Draw one postcard-sized shoreline sketch and one dune rind sketch before you record narration. If you need a pocket model, keep this. Delta V is budget, mass is money, margins are mercy. The descent architecture, power system, and instruments trade across those currencies. Zhurong traded complexity for coverage and put radar where it mattered. Perseverance traded risk for capability and reached a river delta. Multiple programs, multiple bets, one composite map, richer than any single flag could draw. Objections deserve airtime. Could basalt or ash mimic layered radar returns? In places, yes, but the observed dips, continuity, and basin context keep coastal deposition the parsimonious read. Could the crust be ancient, exhumed, and merely look fresh? Unlikely given their fragility under sandblasting and shallow depth, but cores will test it. Could life have nothing to do with any of this? Absolutely. Mechanism first means we can live with that answer. Follow 3 steps for a week and audit your clarity every evening for progress. Follow the data. So what practically should we do with this? Start distinguishing mechanisms from meanings in every science story you share. Ask what was measured, where the instrument sat, and how the geometry limits interpretation. Be suspicious of verbs that smuggle certainty. Reward scripts that show cross-sections instead of chanting breakthrough. The habit reduces gullibility and increases wonder because the real story survives scrutiny. Here is a recap you can repeat without slides. Zhurong's radar image subsurface packages that dip north, consistent with shoreline processes along an ancient basin. The rover also found dune-top salt crust that likely formed from episodic frost-to-brine wetting in the recent geological past. Together, those claims keep Mars dynamic in deep time and near time frames. They do not claim rivers today or microbes tomorrow. They point to where, how, and why to look harder, with samples and patience. Name the instrument plainly, state the geometry firmly, and choose one careful verb deliberately. Use the dates as arithmetic, not magic. 1976 frames the first touchpoint with Viking. 2021 grounds the new subsurface and dune evidence. 2028 commits us to verification in earthbound labs. The microscopes will be merciless and therefore merciful to the truth. When the cores arrive, claims will either survive or change without fireworks. Either outcome is progress measured in grams, spectra, and thin sections. The sober joy here is that a boring landing site produced sharper clues than glamorous terrain might have. Flat plains give radar a calm canvas. Clean geometry tells a clearer story. A new Mars program used conservative methods to chase a dramatic question, and the result is a narrower, better target for the next mission. That is how exploration matures. Less theater, more logistics, and a better signal-to-noise ratio. Underline one sentence in your script that uses maybe and replace it with the mechanism. Landing stays hard. Staying is engineering. The planet will keep whispering through layers and rinds, and we will keep sending better listens. If you narrate with restraint, you will not dampen wonder. You will focus it. Say what the instrument saw. Say what the geometry implies. Say what remains uncertain. Then point to the next tool that can settle it. Keep claims proportionate to the real measurements you can actually defend. Logistics beat hype. Keep the 3 dates close. The 2 mechanisms on a single slide and 1 rule in your voiceover. Mechanism before meaning. If you can hold those without flinching, you'll teach Mars without myth and still leave room for surprise. The planet has not finished speaking. We should stop interrupting it and start listening with sharper ears. For the next 7 days, name the instrument and draw 1 sketch before choosing 1 verb.